A block of mass m is pushed towards a movable wedge of mass nm and height h with a velocity u. All the surfaces are smooth. The minimum value of u for which the block reached the top of the wedge. Okay. Now first of all understand that since all the surfaces are smooth, the energy will be conserved at every point. So I can say that initially the initial momentum over here is, okay, since there is no external force, initial momentum, let it be equal to mu, and the final momentum when the block just reaches the top of the surface. Okay, when the block just reaches the top of the surface, it means that when it reaches the top it stops. Okay, it stops with respect to the wedge. Okay, the block of mass small m reaches the top of the wedge, okay, and it stops with respect to the wedge. Okay, if it stops with respect to the wedge and the wedge is now moving with a velocity v in the left hand side direction, so with respect to the ground the small m is also moving v in this direction. Okay, so I can say that it will be equal to m plus nm into v. Okay, m plus nm into v. Okay, so let this be the first equation. By law of conservation of energy, I can take, or I can simplify the first equation over here. I can take u as, okay, 1 plus n into v. Okay, let this be the first equation. Okay, if I cancel out the m over here. Okay, let us proceed with the second part. By the law of conservation of energy, the kinetic energy at the first point, let this point be a, will be equal to kinetic energy at the second point. So I will be the total energy at the second point. The kinetic energy at the bottom was equal to half mu square, and the total energy at the bottom will be equal to half m plus capital M or nm into v square. This is the kinetic energy, plus the potential energy over here is equal to mgh, we have to calculate the value of u over here. So I can take, if I cancel out m over here, it will be equal to half u square will be equal to half n plus 1 plus g into h. Okay, now over here into v square. Okay, into v square. Now v square, v can be substituted as u divided by 1 plus n square, so it will be equal to half u square. Okay, so it will be equal to half into n plus 1. Instead of v square, I will substitute u square divided by n plus 1 the whole square. Okay, plus gh. So this term will get cancelled out over here. I will take this term on the left hand side, so half u square, I will take it as common, 1 minus 1 divided by n plus 1, okay, is equal to g into h. Okay, is equal to g into h. So it will be equal to half u square, okay, into n plus 1 minus 1, so it will be equal to n divided by n plus 1 is equal to g into h. Okay, so u square will be equal to 2gh, okay, into n plus 1 divided by n. Okay, divided by n. So this term will be, the final term will be equal to, u will be equal to root 2 gh 1 plus 1 by n. Okay, 1 plus 1 by n, which is option number C.